The last part of 5.1 is called resultant of two vectors. So here, say that I have an origin and two coordinates A and B. So let's call vector OA is vector A and vector OB as vector B. Now what if I want to find a new vector AB? How do we do that? So note that to find vector AB, which is from A to B, we need AO plus OB. And since OA is vector A, therefore vector AO is the negative vector. Therefore it is negative A, since AO is in the different direction compared to OA. So AO is negative A, and that will plus with vector B. So we will get B minus A. Now this is by using the concept. An easier method to do this vector AB is just by taking the last letter, which is B, so that will be OB, and then you're gonna minus with the first letter A, which is OA. And we know that this is vector B minus vector A. And that's how you find the resultant vector AB. Now let's look at example 4. So the position vectors of point A and B, so position vector is from origin to any coordinate. So position vectors of point A and B means we're talking about OA and AB. So this is vector A and this is vector B. So I'm gonna let vector OA is A and OB is B. So to find resultant vector AB, I'm gonna take the last letter minus with the first letter. So OB minus OA, which is vector B minus vector A. And hence the final answer is negative I plus 4j minus k. So that's for part A. Next, for part B is the magnitude of AB. Therefore, the answer is negative 1 square plus 4 square plus negative 1 square. Because A is negative 1, B is 4, and C is negative 1. So the answer is square root 18, which is 3 times set 2. And lastly, for part C, we need a unit vector that is parallel to vector AB. So let's say this is our vector AB, and we have another parallel vector. Let's call that vector V. So this vector V is parallel to vector AB. So I need to find what is V, and then I need to find its unit vector. So that's what it means by a unit vector that is parallel to AB. And we know that when two vectors are parallel, we can write it like this. Let V equal to lambda AB, where lambda is a constant, and we know that AB is negative 1 for negative 1. So V is negative lambda for lambda negative lambda. So that's our vector V. So to find V hat, the unit vector, we need the vector and its magnitude. So the magnitude of vector V is the square root of negative lambda square plus 4 lambda square plus negative lambda square. And we will get square root of lambda square. Now, as we know, square root of AB is equal to square root A times square root B. Therefore, this is square root 18 times square root of lambda square, which is 3 set to lambda. And hence, the unit vector V is vector V divided by its magnitude. And note that we can actually simplify or factorize lambda from the numerator, which will give us lambda times negative I plus 4j minus k. Therefore, we can cancel out lambda, and hence the final answer will be negative 1 over 3 set to I plus 4 over 3 set to j minus 1 over 3 set to k. So this is the unit vector that is parallel to vector AB.